morning everyone. So let's begin the first section or first topic of this course, combinatorics. So we will start with two basic counting principles which we are going to use throughout this course. So to begin or to understand these principles, let's consider a very simple exercise which says that let's assume there are 5 different Spanish books, French books and German books. How many ways are there to pick an unordered pair of two books, not both in the same language? So one thing is unordered pair, which means that if you pick a French book, let's say the second one F2 and the German book F3, then these two are same. Either you first pick the German and then the French. Order doesn't matter. Now to approach this problem, we need only two books and they must be different. It means that there could be three possible cases. The first case is I pick a Spanish book and a French book. Now for the Spanish book, I have 5 possibilities. And for the French book, I have 6 possibilities. In total, I have 5 cross 6 possibilities. We will understand that in the next slide that why we have used the multiplication. But for your observation, try to see the problem with, for example, 2 Spanish book and 2 French book. Write down all the possibilities. You will see that, or 2 Spanish book, 3 French book, you will see that it comes out to be 2 cross 3, which is 8. The second case is I pick a Spanish book and a German book. So now the possibilities are 5 cross 8. And the last case is a French book and a German book. So possibilities are 6 cross 8. So 3 sub cases are there, and to have the final answer, I must add them. So why I am adding them, why I am multiplying them? For this I have to look at the addition principle as well as the multiplication principle. So addition principle says that if there are R1 different object in the first set, for example, there were 5 objects Spanish, so 5, then in R2 I have 6 French, and then I have 8 German. So if there are R1 different object in set 1, R2 in set 2 and so on, and if different sets are disjoint, then the number of ways to select an object from one of these sets is R1 plus R2 plus Rn. So the first set was, because I have to pick 2 books, so the first set was Spanish and French. So I wrote 5 cross 6. This is set 1. The set 2 was 5 cross 8 and the set 3 was 6 cross 8. So 3 sets were there because I need 2 books. So set means a set of 2 books. And then the number of ways to select one set from all these possible sets is I must add them. The multiplication principle says that if a procedure is broken into m successive stages. Now what is the successive stages? For example, I have to pick a pair of the book and I pick a Spanish book and a French book. So 2 steps, I break into 2 steps. One is I pick a Spanish book and then I pick a French book. Since order doesn't matter, so that's why it is equivalent to picking a French book and then the Spanish book. In this case, if I break it into the successive orders, then finally the total procedure has R1 cross R2 different composite outcomes, and that's why the outcomes were 5 cross 6. So you can see the difference that in the first case there were sub cases of one problem. In the second case, when there is a sub case, then in the sub case there would be multiple stages. So for the multiple stages we have used multiplication, or for the sub cases we have used addition principle. To understand the addition and multiplication principle, let's see some problems. First problem says that how many ways are there to form a 3-letter sequence using the letters A, B, C, D, E, F. So all 6 distinct letters are there and I need a sequence which is made up of 3 letters. For example, A, B, D, A, F, E and so on, or D, E, C. And the interesting point is when we are making a 3-letter sequence, then the order matters here. If I write B, C, E, then B, E, C is different from this one because all letters are different. So now see the cases. The first case is that with repetition of letters allowed. Please do try these exercises by yourself. So when repetition allowed, I have 3 positions. The first position can be filled in 6 ways because 6 letters are there. Second also can be filled in 6 ways and third also can be filled in 6 ways. And you can see that these are the stages of the problem. They are not the sub cases. So that's why the multiplication principle come into the picture and the answer is 6 cross 6 cross 6. So repetition is allowed, it means this A is acceptable. Without repetition, so now something like ABA is not allowed. So in case of the without repetition, the first position, whichever you pick doesn't matter. So the first position has 6 choices, the next one has 5 and the third one has 4. So in total 6 cross 5 cross 4 possibilities are there. Without repetition and containing the letter E. So this is interesting because now the solutions must have the letter E. So to address this, since there are 3 positions, so therefore I have to break it into 3 cases. The first position may have E, the middle position may have E and the last position may have E. Now if this is clear, then without repetition, which means that E is already done. I have 5 letters and 4 letters for the remaining positions. So I add 5 cross 4, 5 cross 4 plus 5 cross 4. And now you can see that I have used the addition principle because I have break down the problem into 3 sub cases. What could be the another approach? Is it the unique way to solve it? In combinatorics you will see that there are always multiple ways to address the problem. For example, in this case, what you can do is that you can consider all possible cases, which is 6 cross 5 cross 4, and then you can subtract the cases which do not contain the letter E. So if do not contain the letter E, it means there are only 5 letters, and without repetition, so 5 cross 4 cross 3. With repetition and containing E. So in this case, one of the possible approach is 6 cross 6 and then E is in one position plus 6 cross E cross 6, and then at the first position also E can be there, so 6 6, which is 108. Now this is the first thought when we try to solve it. Now think over it that do you find any error in the solution, which means the number is 108. The observation here is that whenever we are finding the number of the possibilities or the number of the ways, all ways must be distinct. There should not be any repetition. We should not miss any case. At the same time, we should not repeat any way. If you see if the repetition is allowed and there are 3 cases like this. So in the first case, if E is fixed here, then what you can do is that for the other position also EE is allowed. So for example EE, and in the same case EE would come, so the solution EE would be repeated. Even there could be other things also. For example, in the first case, if I put C here and then E here, repetition is allowed, I am again getting the same solution. So there is a lot of repetition, and that's why 108 is not the correct answer. It means I need to avoid the repetition. So to avoid the repetition, what I do is that the first case is I put E here and repetition is allowed, therefore 6 cross 6 possibilities are there. In the second case, when E is in the middle, I must say I don't want E at the first position to avoid the repetition. So here there are 6 possibilities, but here there are 5. And in the last case, when E is here, I would say I don't E at the first 2 position, and therefore 5 cross 5 possibilities are there. In total 91 possibilities would be there, 91 ways, different ways would be there. So this is the most important observation of the lesson, that many times when we try to find the number of the ways, we may get the repeated ways, and that may lead to the incorrect answer. Let's quickly see the last question, which says that how many non-empty different collections can be formed from 5 identical apples and 8 identical oranges? Both are identical. Yes. Now when you see of a collection, what does a collection means? You write down something like this: 5 cross 6, which means there are 5 apples and 6 oranges. And when 5 apples are there, since they are identical, we cannot distinguish between them. For us, it's simply 5 apples. So it means I have to see that how many different pairs are there, or there are 2 positions only. First one has 6 possibilities, because apples can be 0, 1, 2, 3, 4, 5, 6. And this one has the 9. So total 54 pairs of the collections can be formed. Different collections can be formed. Only important thing is the non-empty word has been used here. It means the case when there is 0 apple and 0 orange, we should not consider this one. So the final answer is 53. So this is the most basic concepts of combinatorics. In the next class, we will talk about permutation and combination. Thank you very much.